So when we last saw you for Ice on Fire, we were in Zurich and looking at your first installation of 40 machines. How is it going with the actual machine?
Yes, the first time we met was 2017, and we met at our plant in Zurich, Switzerland. There we do have a direct air capture plant capturing CO2 from the air and providing that to a greenhouse in order to stimulate the plant growth inside the greenhouse. And the second thing we're doing there with the CO2 is supplying it to a bottler of the Coca-Cola company, and they produce fizzy drinks with the carbon. Since then, very good news. The plants are still there. They're still operating. They are still on the same filter material. They are operating roughly 80% of the time of the year, which is very, very good news to us. That wasn't the case in the beginning. In the beginning, of course, there were some smaller issues here and there we needed to figure out. But the good news is that over the last 3.5 years, we figured out how to operate in a very reliable manner direct air capture machines. And today we are in a position that we can really provide very robust direct air capture technology, which will be very, very important in order to further scale what we're doing.
We should probably mention, what is direct air capture in just a nutshell?
Direct air capture, in very simple words, is building machines that draw in air with obviously CO2 in it. And air, again, is leaving the units with much less CO2 in it. And the reduced CO2 is provided as high purity feedstock, which can be used for very different applications. For example, for carbon neutral applications, for beverages, for fuels. But it can also be put in the ground in order to go negative or to draw down carbon from the atmosphere. In very simple words, direct air capture is sort of technical trees. So it does the same as trees, drawing carbon from the air, but with machines.
And what you were doing in Iceland, how's that going?
Iceland, well, first, the installation in Iceland is also going well. It has been there for 3 years now. It was precisely in October 2017 when we put it. The Icelandic plant has been a very important foundation for us in order to generate data, in order to scale. And currently, we are very happy to report, there's a huge construction site next to the power plant in Iceland, the Hellisheiði geothermal power plant, where we're currently building a scaled direct air capture facility, drawing more carbon from the air and storing it underground. It'll pull down 4,000 tons of CO2 from the air. It's still, I'd like to say, a match in the eternity of darkness when you compare it to global emissions, but it's a nice scale up.
What are the criticisms, and tell us how those criticisms are going to melt away?
Well, the criticism follows a cascade. And in the beginning, criticism was, hey, direct air capture does not work technically. And with our plans now, we can show that it works technically. Once we show that it works technically, people say, hey, direct air capture cannot be scaled and it's too expensive. Or they say it's only small scale and too expensive. Hence, on our roadmap now is to show that we can scale, A, and B, that we can reduce the cost. The criticism that it produces more greenhouse gas emissions than we're drawing from the air, if we compare apples to apples, that is not correct. Actually, we just did a very thorough life cycle assessment for our technology, or actually not we did it, but a third party, very importantly, not financed by Climeworks, but by public funding. And this study came to a very clear conclusion that the Climeworks direct air capture technology is very capable of reducing carbon from the air in an efficient way, meaning that per ton of CO2 we capture from the air, we do have a reduction potential of 90%, which is a very, very high number and which speaks for the efficiency of the solution. How do we get there to this good number is through two things. A, we're not using scarce materials or rare earth materials, etc. We are using bulk materials to build the plant. And actually, we do recycle most of the materials. And second, we're only accepting renewable energy sources to power our technology. We would not use any fossil sources in order to power the technology. And that consequently leads to the low life cycle emissions of our technology. like among the bigger handles is to get more CO2 out per unit of direct air capture machine. And that is a clear focus of our work. The device has also a new design where our first plant in Zurich looked kind of engineering. The new plant underwent a sophisticated industrial design. We are embedding our device in pristine Icelandic landscape, and we made sure with local designers matching our plant to natural colors we encountered there to emphasize the interplay between nature and this technological piece, and again emphasizing the aspect of positive industry. So that has been a quite important aspect also for the scale-up work and for the next plant we're putting to Iceland.
There are people saying there isn't enough room underground to take all the CO2 that we've thrown up in the sky. And I know that you've said, and I love your quote, that we can save the world 3 times with what you found in terms of space in the ground. Can you explain that? And of course, it's a dream, and it's probably not going to happen only with direct air capture, but there is room to store carbon in the ground.
Yes, very clear message. And I'm sure every geologist on the planet will underwrite that statement, that from a geological perspective, there's more than enough room to reverse or take back all carbon humanity has emitted to date to the atmosphere. To date, humanity has emitted roughly 2 trillion tons of CO2 to the atmosphere, and there's at least 6 to 8 trillion tons of storage potential. Hence, several times the opportunity to save us from extinction, which hopefully we won't need. And again, from a geological perspective, the resources are there. If there were bottlenecks, it is rather the energy that was available, explicitly the renewable energy, precisely at the location where we're storing the CO2 underground. Which again, however, with our system is very feasible, since we can place it everywhere on the planet. So we could go in the sunbelt of the planet and in the windiest regions of the planet in order to capture carbon from the air. When producing renewable fuels from CO2, the question is always, how much do those fuels cost? And we are currently having quite detailed calculations actually with our partners from a company in Germany called Sunfire, and also a company we started together in Norway called Norsk E-Fuel, which is a project company to develop renewable fuels projects. And that Norsk E-Fuel company assumes prices in the range of €1 to €1.50 per liter of fuel produced from renewable electricity and CO2 from the air, and in such a CO2 neutral renewable fuel, which of course is more expensive than a fossil equivalent. However, it is definitely within the boundaries of being attractive to certain applications like aviation, shipping, long distance transport, etc.
For people who aren't in your field, that's exciting. I don't know, you should do more on that. You should speak out more. I don't know what your marketing campaign is going to be like.
Believe us, we are full steam ahead in all our applications, where the most important applications are the production of fuels.
Amazing. Okay. Anything else?
Leila, you didn't ask me what you said you asked me. What happened since 2017? But
I thought I did. Let's do that. What happened since 2017? I thought that's what happened. What else happened?
Since 2017, when we did the filming for Ice on Fire, you could say that almost everything, or to most people in our field, they would say that since 2017, everything in our field happened. Since 2017, really major things happened. Externally from Climeworks, the IPCC released a report in 2018, which said that carbon removal is absolutely needed in order to achieve climate targets. And actually 100, every modeling scenario consistent with a 1.5 degree target assumes carbon removal. That has been a breakthrough for what we were or for what we are doing, and put a lot of wind in our sails. And well, my interpretation is that triggered a lot of climate pledges from leading companies. So since then, in the last 3 years, you have seen very big and very prominent climate pledges, like, for example, from a Microsoft, from tech companies like Shopify and Stripe. And based on those climate pledges, you have seen, so as the third thing, you have seen really companies putting money for removing carbon from the air with machines. The German car maker Audi as pioneers to really advance this technology. Solution for everyone available, like Climeworks subscriptions, like sort of democratizing, reversing climate change. We're giving everyone the chance to take carbon back out of the air. And so consequently, quite substantial developments, definitely also thanks to Ice on Fire. I'm sure many people were motivated. I hope the next 3 years will the same X factor.
Well, we need it to be. We need that X factor because we need you guys to be successful, because if you're successful, the planet will do better and humanity will have a better chance. So I'm excited to talk to you, and I really am happy to hear that things are going well. And one day I'm going to talk to you about how hard it was to get it going.
Well, you can see it here, I think.